Dear students, in this presentation, we will discuss how to convert infix expression to postfix form. This is one of the application of stack where to convert the given expression from infix to postfix we use stack. When I say stack, we'll be performing push or pop operation. Push whenever we want to add symbol on top of the stack, pop whenever we're going to remove a symbol from the stack top. We'll be using two different types of stack, one to hold all the operators, other one to hold the final output, the output expression. In case of operator stack, we call that as OP stack, which will permit us to perform push and pop operation, and that OP list, that output stack, will allow us to perform only push operation. There are three different types of expression. So the type of expression is based on the place of operator. If operator is placed between two operands, as you can see that in the first example where operator is placed between two operands, that type of expression is called infix expression. There is another type of expression. It is also called Polish expression or prefix expression, where operator appears before the operands, as you can see that in the second example. The other one is the postfix expression or reverse Polish expression, where operand appears first, then the operator. Based on number of operands, operator or operation can be binary operation or binary operator or unary operator. Like in the first case, that minus takes two operands A and B. So here that subtraction or addition or multiplication or division, these are all binary operation. Minus is used for binary operations. In the second case, it takes only one operand to change the sign of a number, to change the sign of an operand, where it takes only one operand, so it is unary operator. So when minus appears in the expression, we may get confusion whether it is a unary or binary. That can be easily solved with a small alteration or the modification to the exam given expression. We will see that while solving the problems. Before that, before looking to the conversion, we'll see what is that associativity, what is that precedence. Here I have listed only important operations or operators. The highest priority, highest precedence will be for unary minus, whose associativity is from right to left. The operand sign is negated. Operand sign is changed. Operand in the right side, the operator in the left side. So it is from right to left associativity. In the same way, the operand can also be negated. An operand can be complemented, but it is from left to right, which has got little lower precedence. A number can be raised to another number. We call that as exponentiation. Exponentiation is usually represented in the mathematical expression, the caret symbol, or you can have a dollar mark or a pipe with a caret symbol. The associativity of this is from right to left. We'll see why it is right to left, why it is left to right in the next slide with example. Then we've got multiplication on division modulus. This is the left to right associativity. Then next lower precedence operation is addition and subtraction. Then we have got shift, logical relation, and that relation operator, equality, bitwise and or XOR, logical and or. These are as usual that mul or div kind of thing, left to right. We'll see with some examples. In the first case, where I performed addition operation 1 plus 2 plus 3. When we perform the operation, we start from left side to right side. We reach to the right side. The associativity start from left to right. In the first example, we'll be adding 1 and 2. That result is added to third operand. Operation that is performed first is 1 plus 2. That is added to the next operand. So precedence here it is same. The plus, both plus has got same precedence. When precedence is same, we have to consider the associativity. Which side you have to start, from left side or from the right side. In this case, it is from left to right. In the next example, where I am performing subtraction. 2 is subtracted from 1, which is the leftmost operation. That is performed first, 1 minus 2. Then that result is subtracted with the 3. The answer is minus 4. Here again, minus has got same precedence. When precedence is same, we have to go for considering left to right or right to left associativity. In the third example, I'm multiplying three numbers. The leftmost multiplication is done first. The result is multiplied with the third operand. Like before, the associativity is left to right. In the fourth example, using division operation, division. 1 by 2 is performed first, which is the leftmost division. That result is divided by 3, which is the next one. So here again, precedence is same. The associativity is left to right. In the next example, 2 raised to 3 raised to 1. Here, 3 is raised to 1. That is performed first. Then 2 is raised to that answer. Unlike the previous one, this is of different associativity. Even though the exponentiation has got same precedence here in this expression, but the associativity is right to left. That is why 3 raised to 1 is done first, then the leftmost. So the associativity start from right side to the left side. So associativity depends on the type of operation that you are performing. In the next example, 1 plus 2 minus 2. Plus and minus has got same precedence as you've seen that in the previous slide. 1 plus 2 is performed first, then 2 is subtracted. The leftmost operation is plus, that is performed first. Precedence are same. The associativity is left to right. Whichever the operation with the same operator comes, no, that we have to perform first. In the next example, 1 minus 2 plus 3. 1 and 2 are subtracted because it is the first in the leftmost side. That result is added to 3, which is the next. So associativity starts from left to right side, even though precedence are same. In the next example, 1 into 2 by 3. 1 and 2 are multiplied because this is the leftmost, so this is performed first. The result is divided by 3. The precedence is same, associativity is considered, which is left to right. In the next example, 1 by 2 into 3, the leftmost operator, the leftmost operation, that is division, is performed first. That result is multiplied by 3, which is the rightmost. In case of division and multiplication, the associativity is left to right. In the next example, this is something special. Here, the expression consists more than one operation, but of different precedence. The precedence, if there is no bracket, then 2 is multiplied by 3 first because which is of higher precedence, where the associativity rule is not applicable. But I want to override that. I want to do that addition operation first. For that, the things that you want to perform first, even though if it has got less or precedence, you have to enclose that inside the bracket. So 1 and 2 are added first, then the result is multiplied. Here, the, because you put that plus inside the bracket, which will get higher precedence. The bracket, the things which are there inside the bracket will get higher precedence. So 1 plus 2 is performed first, then that is multiplied by 3. In the last example, 1 plus 1 plus 2 into 3 minus 6 power 2. Here there are 4 symbols but are of different precedence. As we have seen that in the previous chart, hierarchy of operation, the exponentiation has got highest precedence. Here associativity is not applicable. You cannot consider that because first is the precedence. If precedence is same, then you go for associativity. So 6 is raised to 2. 6 is raised to 2. Okay, 6 square. Then the answer becomes 1 plus 2 into 3 minus 36. In these three, the star has got next precedence. The answer becomes 1, 2 into 3, 6 minus 36. In these two, the leftmost has got highest precedence. The associativity is left to right. So 1 plus 6 is 7 minus 36. The final answer is 29. To convert the given infix expression to postfix, we have to keep few of the points in mind. This may be considered as guidelines or rules, which will simplify our work, which will solve ambiguity if any. It will solve the problem with more clarity. The first and foremost thing that you have to see that the expression consists matching number of brackets. The number of open bracket, that is left parenthesis, must be equal to number of right parenthesis. That should be same. If the number of brackets open and close are same, then we can solve, that is we can convert infix expression to postfix form. The first guideline is that for the given infix expression, you have to add or append one right parenthesis at the end of infix expression. Suppose the expression is a plus B. As per this guideline, you have to add one right parenthesis at the end of the expression. As I told earlier, we are going to have a stack to put operators. We are going to have a stack to hold operators. That stack is initially empty. That stack is known as OP stack, operator stack. Initially it is empty. After emptying that stack, add one left parenthesis to the stack. You have to add one left parenthesis. Why this is required will come to know once we solve the problems. This is the second guidelines. To the empty OP stack, you have to add one left parenthesis. We have to have one more stack, that is OP list. Initially again that is empty. The purpose of OP list to hold all the operands and operands in the postfix form. First operand appears, then the operators. If at all any unary symbol present in the expression, you have to resolve that you have to resolve that manually before conversion. For example, if my expression is a plus b, this a is unary. This a has got unary minus. For unary operation, you bring that you convert this to 0 minus form. By using this now, the value of a will not change. You are subtracting a from a, answer is minus a. That means you are converting that unary to binary. If at all any unary symbol present, you convert that into binary form. So this is the next guideline. In some cases, if at all any ambiguity in the expression, resolve that manually before the conversion. Like what we discussed earlier, a raised to b raised to c. Here there is some ambiguity. We don't know which one is executed first, whether it is a raised to b first or b raised to c first. In that case, you have to resolve that by using bracket. So you put the bracket properly. So as we know that b is raised to c first. Put bracket, enclose b power c inside the bracket. This is the next guideline. So resolve right associativity with the bracket. If at all any ambiguity in the expression, you put that inside the bracket. These are the things that one should note. Then you have to start scanning the infix expression from left side to right side. Each time you have to take one symbol at a time. Scan one character at a time from left side to right side. Each time only one character is allowed to process it. Either it can be added to the stack, can be popped from the stack, or can be added to the OP list, output list. While doing so, we may get different types of symbol. Symbol can be operand. Here A is an operand, B is an operand. The symbol can be operand. We call that symbol as token. A is a token, plus is a token, B is a token, like that. If it is a operand, if the token is operand, you have to add that to OP list, output list. Just add at the end of OP list. Okay, A will go to OP list, B will go to OP list, C that will go to OP list. That is the first rule that you have to remember. If the token is operand, append it to the end of OP list. The second rule is that if it is left parenthesis, in this case this is a left parenthesis, in this case this is a left parenthesis, If it is a left parenthesis, you have to push that open bracket left parenthesis to the stack. That stack is for operators. That is OP stack. To the OP stack, you have to push that left parenthesis. This is the second rule. The third rule is that if the token is closing bracket, the right parenthesis, if the token is right parenthesis, you have to pop all the symbols till the corresponding open parenthesis, till the corresponding left parenthesis. All the operators that you have to remove, all the operators that you have to remove, and you have to append to the OP list. You have to append that to OP list. You have to remove the operator from the OP stack and you have to append that at the end of OP list. This is the rule number 3. The next rule, rule number 4, if the token is operator, here it is plus, here it is minus, here is exponentiation. If it is an operator, push that to stack. While pushing that operator to the stack top, you have to see that its higher precedence symbol, its equal precedence symbol, if the symbol that is scanned, the token is minus and stack has got plus, minus and plus has got same precedence. You come to know once I start solving the problem. This is the symbol that is scanned, this is the symbol which is there in the stack. Minus and plus has got same precedence. In that case, the plus must be removed from the stack. This plus must be appended to the OP list. In this place, this token must be loaded. Minus must be pushed into stack. This is the case number 1. When the equal precedence symbol appears, the minus and plus has got same precedence. If the incoming symbol is plus and the stack symbol is also is minus, they have got same precedence. In that case also, equal precedence symbol must be removed. Minus is removed, that should be added to the stack, then plus is added. A part of this rule says that if the stack has got, I will take that here, if stack has got asterisk and the incoming symbol is minus, asterisk, that multiplication has got higher precedence over subtraction. The rule says that you have to add this symbol to OP stack, but while adding that to OP stack, the higher or equal precedence symbol must be removed. Star is of higher precedence, that must be removed. So star will be adding, we are going to add that popped symbol star to the OP list. The OP list will get star. In the same way, if incoming symbol is star, the stack symbol is minus. The minus is lower precedence over star. So you need not remove this minus because it is lower priority. So this symbol is added to stack. When equal precedence symbol appears, you have to remove the existing equal precedence symbol and you have to add that to OP list. The scanned symbol must be added to OP stack. OP stack. If higher priority symbol appears in the stack, that must be removed, must be added to OP list. If lower priority symbol appears in the stack, then no need to remove that, just append that new symbol at the end of the stack. To get more clarity, we will solve some 4 or 3 problems of different varieties, different in nature. Okay, we will be solving these 3 one by one. First, I'll be picking the first problem. We'll solve that problem by applying all the rules. There is no ambiguity in the expression, so no need to put anything inside the bracket. That rule need not be applied. In this expression, there is no unary operation, there is no unary operator, so no need to put that in 0 minus form. One of the rules says that you have to add one closing bracket at the end of the expression. So modified expression is by adding a bracket. See that the number of brackets are same, but here one is extra, that is as part of the rule. Other than this, the number of brackets same, one open bracket, one closing bracket. So the number of brackets are matching. This is the extra bracket that is added. Now we'll be starting converting that infix expression to postfix form. We will write that in the form of column. This is the symbol that is scanned. The first column, that is the symbol that is scanned. A stack called OP stack will maintain operators. The other one is OP list, the rule that is used. Initially, OP stack is empty. For that empty stack, add one left parenthesis, that is as part of the rule. In this expression, the first symbol is A. As per the rule number 1, if it is an operand, if the token is an operand, add that at the end of OP list. As OP list is empty, that symbol is added to OP list as per rule number 1 because A is operand. The next symbol is logical AND operation. Right now we don't have any symbol, so no need to pop any symbol from OP stack. So ampersand is put into stack on top of the stack. No changes in OP list. We have applied rule number 4 because ampersand is operator must be pushed to OP stack. The next symbol is B. B is operand. You have to add that to OP list. As per rule number 1, B is operand. So that is added to OP list. The next symbol is OR. Logical and logical are of same precedence. If precedence are same, the equal precedence symbol must be removed from the stack and must be added at the end of OP list. So ampersand is removed. So OR will come to this place. Ampersand is added here. This is as per rule number 4. Ampersand and OR has same precedence. So is popped. Ampersand is popped. That is added to OP list. The next symbol is C. It is an operand as per rule number 1 that is added to OP list. Rule number 1 says that if the token is operand, C is operand. If token is operand, append that at the end of OP list. So C is operand, so it is appended to OP list. The next symbol is OR. Already one OR is there, that you have to remove. The input or incoming symbol OR must be added to the stack. This popped symbol must be added at the end of OP list. This is as per rule number 4. So OR and OR has same precedence. So the stack OR is popped. The next symbol is the not, the negation. The negation has got higher precedence. The stack symbol is of lower precedence. So no need to remove the stack symbol. Add that negation to the stack. The existing symbols in OP list are same. This is as per rule number 4. You need not no need to remove lower priority symbol. The or is of lower priority, so no need to remove. The next symbol is open bracket must be added to OP stack. So this part is as it is. As per rule number 2. The rule number 2 says that if it is left parenthesis, push that to OP stack. The next symbol is E. E is operand, so that is added at the end of the expression as per rule number 1. E is appended to OP list. The next symbol is greater than symbol. As we don't have any more symbol inside that bracket, we don't have any symbol here, so greater than symbol is placed there only. And OP list unchanged. This is as per rule number 4. Next symbol is F. The symbol is operand. Add that at the end of stack, end of OP list. This is as per rule number 1. The next symbol is closing bracket. The rule number 3 says that if the symbol is right parenthesis, you have to remove all the operators till the left parenthesis. Removed operators must be added at the end of OP list. So greater than symbol is removed, that is added at the end of OP list. This is as per rule number 3. Greater than symbol is removed and appended to OP list. Appending means adding at the end. The next symbol is bracket close. The rule number 3 says that you have to remove all the operators till corresponding left parenthesis. Removed symbol must be added to OP list. So first negation is removed. The next or is removed. This is as per rule number 3. First negation is popped, then or is popped. These popped symbol must be added to OP list, that you have to remember. So the final the OP stack is become empty, no more symbol available. So the final answer is AB ampersand C or EF greater than negation or. So this is the final answer. Just have a look. Now we will solve one more problem with different types of operation. Now I'm going to take another type of problem which involves some more type of operators and unary operation. If one of the guidelines says you have to compare the number of left and right parentheses. The number of left and right parentheses 1 and 1. So no problem, the expression is proper. You can proceed. If there is an ambiguity, resolve that using brackets. So no ambiguity in the expression. If there is a unary operator, minus is unary, resolve that by using 0 minus form. So I'm going to use 0 minus form for A. I'm going to put that inside A just to resolve that. Not necessary. 0 minus A dollar B into C minus D plus E or F or 1 G plus H close. One of the guidelines is you have to add closing bracket at the end of infix expression. So this expression becomes like this. After adjusting these kind of thing, start solving by scanning the symbols from left to right. We'll make some three columns. The first column is symbol, second column is OP stack, the next is OP list, the rule that is applicable. Nullify the stack, empty stack is formed now. To that add one bracket. Open bracket is appended to stack. Stack was empty, open bracket left parenthesis added. We'll start scanning the symbol. The first symbol is open bracket as per rule number 2 left parenthesis is pushed to OP stack. The next symbol is minus. The minus must be added to the OP stack because it is an operator. This is because of rule number 4. Minus is operator. Operator must be added to operator stack. Operation performed is push operation. The next symbol is A. A is operand that must be added to the OP list at the end. As OP list is empty, to that empty list A is appended. This is because of rule number 1. A is operand. The next symbol is closing bracket. Third rule says that remove all the operators till the corresponding left parenthesis. Removed symbol must be added at the end of OP list. So minus is removed, minus is appended at the end of OP list. The list becomes A minus as per rule number 3. Minus is popped and appended to OP list. The next symbol is dollar. It is for exponentiation. Add that to OP stack. Here no changes. As per rule number 4, dollar is operator. So pushed to stack. Which stack? That is OP stack. The next symbol is B. B is operand. Add that to OP list. This is as per rule number 1. B is operand. The next symbol is star. Star is operator. You have to push that into OP stack. While pushing, the higher or equal precedence symbol in the stack must be removed. Already dollar is there which is of higher precedence. That must be removed. That removed symbol must be added at the end of OP list. So star is added here. This becomes A minus B dollar because rule number 4 says that higher priority symbol must be removed. Dollar has higher precedence. The next symbol is C. C is operand. As per rule number 1, operand must be pushed to stack. OP list. That stack is called OP list. Only push is permitted. C is operand. The next symbol is minus, which is operator, must be added to the stack. While pushing, higher or equal precedence symbol must be removed. So star is of higher precedence, star must be removed. This is the result. This is because of rule number 4. Star has higher precedence. Star has higher precedence, so it is removed. Removed and appended at the end of the stack. The next symbol is next symbol is D. D is operand. Operand must be added at the end of OP list as per rule number 1. D is operand. Next symbol is plus. Plus is operator. The rule number 4 says equal or higher precedence symbol must be removed. So minus is removed. That must be added at the end of the expression. So this becomes like this. This is as per rule number 4. Minus is removed and appended to OP list. Plus is added, plus is pushed to stack. The next symbol is E. E is operand, so that is added at the end of OP list. E is added at the end of OP list. This is because of rule number 1. E is operand. The next symbol is R. Next symbol is R. The R is of lower priority. Higher priority symbol must be removed. So plus is removed. That is added at the end of the expression. The rule number 4 says higher or equal priority symbol must be removed as higher precedence. The plus has higher precedence. So it is removed. The next symbol is F. F is operand. Operand must be added at the end of OP list. F is added at the end of OP list because of rule number 1, which says that operand must be added. Must be F is operand, so must be added to OP list. The next symbol is open bracket. Add that to OP stack. Rule number 2 says bracket, if the token is left parenthesis, this left parenthesis must be pushed onto stack. The next symbol is G. G is operand. So operand is added at the end of the stack, OP list stack. Rule number 1, because G is operand. The next symbol is plus. Plus is added to OP stack because there is no other symbol, so no problem, we can place that plus in OP stack. The next symbol is H. H is an operand that must be added at the end of OP list because of rule number 1. H is operand. The last symbol, next symbol is bracket close. Bracket close, if right parenthesis appears, the corresponding left parenthesis must be removed. All the operators that are there in the OP stack must be removed. After removing that operator must be added at the end of OP list. So plus is removed, the plus is added at the end of OP list. This is because of rule number 3. Rule number 3 says that you have to remove all the operators till corresponding left parenthesis. So plus is removed and appended to OP list. The last symbol that we are going to scan is right parenthesis. We'll scan that also. Remove all the symbols till the corresponding left parenthesis. Add that operators at the end of the list. So this OP stack becomes empty or will be added at the end of expression because of rule number 3. Think I missed one symbol, it's okay. In this way, the infix expression is converted. Here one symbol missed out, it's okay, no problem. Okay, for this, I will alter that expression. For this infix expression, the answer is this one. You can verify that, but remember the process. We will solve one more problem. We'll solve one more problem. Okay. Point number 1. If there is an ambiguity, resolve that with a bracket. Here there is no ambiguity, no need to put that inside the bracket. No unary operations, so no need to express that in the form of 0 minus. Directly you can start solving the problem. Add one right parenthesis at the end of the expression. Append right parenthesis at the end of expression. Let me, this expression becomes with one extra bracket. We'll start solving the problem. Make use of stack, OP stack, another stack, OP list. The first symbol is A, sorry, initially OP stack is empty. To that empty stack, add one left parenthesis. The symbol that we are going to scan is A. A is operand. If it is operand, add that to OP list. So A is added here. Rule number 1. A is operand. The next symbol is, okay, this is solved, I guess. Anyway, this already solved, so I'll not be repeating that. All these are solved earlier. Okay, already solved. I'll take this problem. This one. There is a right to left associativity, that's a ambiguity. For that, now you have to resolve that by putting that inside the bracket. An alternate expression. The problem is now changed. This is my expression. I'm putting that inside the bracket to resolve the ambiguity. Second, append closing bracket at the end of the expression. So expression now becomes like this. There is no unary symbol that you can solve it. First column symbol, second column would be stack, third column would be list, the next is rule. The first symbol is A, A is, no sorry, initially OP stack is empty, add one bracket, the symbol that we are going to scan A must be added to OP list because of rule number 1. The next symbol is power, can use dollar, pipe caret or a caret symbol, anything is okay, but you should not have any confusion. Add that symbol, add that operator to the OP stack. This is as per rule number 4. If it's an operator, add that to OP stack. The next symbol is open bracket, add that to OP stack. Rule number 2 is open left parenthesis pushed to OP stack. The next symbol is B. B is an operand, add that to OP list because of rule number 1 which says that if it is an operand that must be pushed onto OP list. The next symbol is power, add that to OP stack because of rule number 4. No need to check any precedence because no operators found. The next symbol is C. C is operand, add that to OP list. Rule number 1 says if it is operand, add that to OP list. Next symbol is closing bracket. Remove all the symbols till corresponding open bracket. The removed symbol must be appended at the end of OP list because of rule number 3. So ABC caret. Rule number 3 is popped and appended to OP list. Popped from the stack, appended to OP list. The next symbol is star. You have to add that to OP stack by pushing. You have to see that its higher precedence symbols or equal precedence symbols are removed. The power exponentiation has higher precedence, that must be removed now. So ABC power. The rule 4 says higher or equal precedence must be removed. Is higher the power rise of higher precedence. So it is removed. The next symbol is A. A is operand. Add that to OP list at the end because of rule number 1. A is operand. The next symbol is plus. Plus is an operator to ensure that its higher or equal precedence symbols removed. Star is of higher precedence, so it must be removed. So plus here, star is popped and added at the end of stack because of rule number 4. Star is removed and appended to OP list. The next symbol is B. B is operand that is appended at the end of OP list because of rule number 1. B is operand. The last symbol added one extra bracket if that closing parenthesis appears till the corresponding open parenthesis, all the operators in OP stack must be removed. Those removed operators must be added to OP list. Here, after removing plus, OP stack becomes empty, plus is added at the end of the expression. So, for the given infix expression, the postfix form is ABC power A star B plus. This is the final answer. This is how you can convert infix to postfix form. In the next presentation, we will see how to evaluate the given postfix expression. With that, I'll be ending this presentation. Thank you.